So I want to thank you for putting this together. This is one of my favorite meetings. I learn more new and exciting things in one day with the Sci-Fu crowd than in many of my other groups. I hope that none of my colleagues are here and hearing this. In case I run out of time, I wanted to quickly flash pictures of all the amazing people in the lab that have done all the work. I am merely an ambassador here to relate some of their ideas. Let's start. I want you to spend a few seconds to take a quick glimpse at this image and think about what is happening here. The last decade has seen incredible progress in artificial intelligence. We have algorithms that can detect people and ties and shoes and many other objects. We may soon be able to segment and label every single object in an arbitrary image. And yet, I contend that we want much more than object labels from algorithms. This image is intended to be humorous, with Obama being playful. Deciphering what is happening here requires a lot of what I will refer to as common sense. You need to understand that many people may be self-conscious about their weight, that this gentleman is standing on a scale, that Obama is exerting a force with his foot, therefore altering the weight measurement. Furthermore, all these people are in on the joke, except for the man on the scale who's not. How can we teach AI all of these things? How can we inculcate common sense into machines? We investigate how common sense is implemented in the brain, and we want to educate the next generation of AI systems. To illustrate some of our experiments, I want to start with a quick test. What is the object inside this white box? There are no tricks, no distortions. This is a real and pretty common object. In the interest of time, I will not collect your answers here. If you have no idea, that's fine. Fewer than 5% of people can recognize this object. However, once I add the contextual information, it becomes rather easy to recognize the object. More than 95% of people can recognize the object in the white box when full contextual information is provided. Common sense does not require solving complex equations about the physics of the scene or having deep knowledge about human psychology. Even a child can perform these computations in a fraction of a second. I want to do a quick plug-in here for our recent book where we articulate how dissecting computations in neural circuits can inspire new efforts in AI. To build better algorithms, we want to understand the inner secrets of the computations that transpire in the brain. Nervous systems are the products of millions of years of evolution. And despite notable advances in AI, even children and most animals can solve cognitive problems more efficiently, robustly, and accurately than the best supercomputers today. Back to the experiment that I just showed you, we can run controlled experiments where we present stimuli for a fraction of a second, make sure you don't move their eyes, etc. We have run multiple experiments of this flavor to elucidate the basic principles of how we use common sense information in visual cognition. This plot shows accuracy in an object recognition task similar to the one you just did. The x-axis shows objects of different size, measures in degrees of visual angle. 1 degree is approximately the size of your thumb at arm's length. The black bars show the full context condition, and the light bars denote the minimal context condition. The difference between the two illustrates what you just experienced, the contribution of common sense contextual cues. Our goal is to teach computers to see and interpret the world the way we do. This slide is rather complex, and I won't be able to do justice to it and explain the model in any depth. Suffice to say that we incorporate key ingredients from neuroscience. For example, for the aficionados, we use a divide and conquer strategy with two streams, a foveal component and a peripheral component. We also use information from the behavioral experiments like the one you just did. Combining these two streams, we teach the model to jointly reason about objects and their interactions with the rest of the image. So here again is the human behavioral data that I showed you on the left, and on the right, here's the output of the computational model. And even though these are only initial steps to understand common sense, the model can capture, at least at a qualitative level, how contextual cues can facilitate recognition. A fundamental tool to stress test humans and machines is to consider images where we violate common sense rules. For example, none of these amazing computer vision algorithms can detect the backpack here on the left, sitting next to delicious beef and rice, or this enormous chair in a parking lot. It is very easy to trick the best algorithms out there. These failures are important not only from an academic standpoint to understand robustness and generalization, but also for the myriad of applications of AI pattern recognition systems. To systematically violate contextual cues, we're using computer graphics where we can rigorously make pigs fly, mugs levitate, change object co-occurrence statistics, change the expected object sizes, colors, textures, and many other violations of common sense. This is my last slide. I do not want to leave you with the impression that we have successfully instilled common sense into machines yet. However, we're still quite far. However, we think that we're on the right track. We take a four-pronged approach. We study neural circuits, and here's a list of many properties of brains that we think are critical to elucidate common sense. We also systematically scrutinize behavior to learn from the best. We use computer graphics and other tools to create custom data sets to stress test machines and humans. And last, but certainly not least, we combine all of the pieces to build novel AI algorithms and teach those algorithms how to reason about a scene. Here on the bottom right, I am showing all the people in the lab right now. None of the work here would be possible without them. And here on the left is my contact information if you want to learn more or talk about these topics. Thank you.